Hello, everyone. My name is George Hendrickson. These last few months, I've been leading an undergraduate research project into exploring network forensics and IoT devices. And as a part of that project, then I've committed to creating a series of videos as well as some lab projects for more undergraduate students to have an easier time getting into research, adapting to the research experience, and making sure that their transition into research work is as smooth as possible. And I'd especially thank the Hacker Initiative nonprofit for sponsoring my research and this video guide. We'll cover a bunch of things here. Just general advice for beginning networks forensics research. That's what my experience was in, and so that's what it'll be mostly targeted towards. I think you'll find a lot of the advice is applicable to different research projects, especially in computer science. We'll have starting out advice for people getting into research, tools, which I found indispensable in network forensics, and even some demonstrations of those, as well as research best practices. Here's some starting out advice. The first part of a research project is going to be choosing a subject. It's got to happen, and it's often the hardest part. There's no precedent for it. You have to understand the field well enough to know what is going to be helpful, what is going to be likely funded, and what hasn't already been completely explored. Most important thing is to be creative about it. Think about anything. Try to open your mind. Think about any aspect of your field which could use work. For me, the inspiration for what to do with my project was just the fact that there happened to be a ring security system lying around the office. You can't underestimate what's going to be valuable to the field. You're an undergraduate student. Be realistic about what you're actually going to produce. No, you're likely not going to produce any kind of incredible technology or a fantastic new tool. However, what you can do is fill in some gaps, pick some low-hanging fruit, cover some basics. For example, ring security had been researched well before. Many people over the years have found things about ring devices which were not secure and aspects of them which could easily be compromised or broken into. What I was able to do with my research is, in large part, find which of those things were still unfixed flaws, even as much as 10 years later. And I found a way to synergize my work through that way with pre-existing work, instead of saying, oh, people looked at this already and dropping it. Though an important caveat to keeping it realistic for an undergraduate is not to do something too safe. Shoot for something which is just on the edge of feasible, something you might be able to do, maybe not, aren't sure, because as you go, your skill set will improve to match the assignments you give yourself. To truly expand the field and produce valuable work, then you want to remember that you need to shoot in the dark a little, step outside of your comfort zone for it. I mentioned finding prior work, and this is a very important part of it. To produce ethical research, you can't be plagiarizing or reproducing someone else's work. That doesn't help anything. It likely won't get published. Instead, you want to go and find as many other people who had your same idea and already explored it as possible. Take their work, find out what they did, compile that together, and then use that to help build your project and find what in your project is going to stand out and make it unique. Later on, when we discuss applying for grant funding or applying to funding bodies or for publication, then showing you have a good understanding of prior work in your area of research is really important for showing you did your due diligence, you're dedicated to your work, and you try to produce something ethical and high quality. Once you have your idea of what you want to do and your prior work, you want to put together a proposal for it, which first is most important for research just because, especially in network forensics, when you're starting out, you'll find new things. Once you choose your topic and get into it, things will pop up that you think, oh, maybe I should have researched this instead. It'll look easier or more interesting. And you want to remember that you have a direction to your research. You can't search everything at once, and you want to go deep, not go wide. Find one specific thing and really drill down it in your research instead of bouncing between a dozen different topics. Necessary for grant or funding applications. Having a good proposal is a baseline requirement for every kind of grant request or proposal to a publishing outlet. If you want to see your work end up in a journal, or you want to get grant funding for it, then you'll need to have a concise explanation of what you're trying to do, how you're trying to do it, and what it's going to look like throughout the process. To make that happen, then you want goals for your project. You want to outline clearly what exactly you're trying to figure out, produce, do, or develop. You want a schedule for it. This is especially important back from point one for keeping your research directed. Have a schedule for how long you're going to work on each section of it, and most importantly, when you plan to wrap up. And lastly, deliverables, what wrapping up is going to look like. When you come out the other end of this, what are you going to have? Is it going to be a new tool you developed? Is it going to be the results of a number of hypotheses tested, positive or negative? What are you going to be able to give them at the end? And then calculate the cost. You likely won't have all the equipment you need for any kind of research. Certainly, you might not have the software, you might not have the right computers. So add up how much it will be if you really commit to your research, given the topic you want to do, and go look on Amazon, look on anywhere, Best Buy, anywhere that has the equipment you want, and tally up the costs so that when you apply to a funding body, then you'll be able to tell them, here's an itemized list of what I think I'm going to need. Here's why I need the money. And of course, in your proposal, account for what you're going to do with your research. If it's just developed in a vacuum, it does no good to the field at large. You want to take it to conferences and you want to publish it. Conferences are an excellent place to start. Good for, as we'll explain later on, a lot of your next steps in life after research, moving on to higher level research or into an academic institution. Having a conference on your resume is important for that. And particularly, it'll get you a chance to get exposed to new things as well. You won't just be presenting, you'll be hearing others' work, get new ideas on where to go, maybe get some feedback on your work by others who have expertise in the field. The best place to start looking for conferences is your university, and the best place to start looking for publishers is online, but we'll cover those in a second. Just make sure that the ideas, what you're going to do in regards to those things, is in the proposal as well. You'll need a good lab space, of course, to do your research, and you can't underestimate the value of this. Since the most important part of good science is ensuring that you know exactly what you did to produce the result. You know that when you ran this program, it caused this to happen on your computer. It wasn't the game you're running in the background that made it happen instead. In a more general sense, you want your lab space to be influenced from outside as little as possible. Namely, you want good internet, so you don't start getting strange results that turn out to just be packet loss. And good cellular too. You'll be looking up a lot of things on your phone, especially if you have all your computers at work on a certain project. You'll want dedicated machines for your research. Computers that have the storage and processor power to handle everything you need them to do. And importantly, that other people won't have access to. You definitely don't want others getting on the computer, tampering with it, just doing things, installing things, which might compromise the integrity of what you're doing. Or even if they have good intentions, they could install something which may cause your results of an experiment to change, and you don't know about why it happened. It should be uninterrupted, ideally. Well, working on research is work, first and foremost, and at times it can get tedious. It's going to be bad enough sitting there and committing yourself to doing your job, taking steps, following your plan, without having people walking in, coming past, making noise around you all the time. Same as you would for a difficult homework assignment. So make sure it's a quiet space if possible. And of course, secure, especially if you bought computers or other equipment or valuable things that you need for your research. Make sure that no one's going to just walk in and leave with them. Don't leave them in a public computer lab, for example. Another part of your lab space is likely going to happen digitally. Set up a place to record and document your whole process. Among things you want to document is everything that you installed on or added to your research machines. So take the place of just a disk file of your machine, if that's the kind of thing you're doing, where it has to be arranged in a certain way for your results to work, or just any other things which might influence the results of your work. You want to document all the experiments you tested and the results of those, as well as confounding factors, which is a bit of a research speak for outside influences that may have been the cause of your results rather than your experiment. Documentation is important because not least you won't get published without it, and also because it means you really aren't actually producing any quality research or science. If no one understands how you got your results or no one else can reproduce them, then it's effectively junk work. There's nothing anyone can do with that. So first, ethics are important, not just because you don't want to face any criminal proceedings for stealing someone's work or lying to your funding agency, but also because you respect your project, you want to produce something good, and to produce something good, you need to explore the unexplored. Make sure your work is reproducible. Make sure somebody else following your research instructions can achieve the same thing you can do, so that they can take on your work later and make something else out of it. Produce a new hypothesis that you never thought of and test it in the same way you did, or take your work and build on it in any other way. Cite your sources and prior work. You want to avoid plagiarism if you can. And negative results are okay. Don't feel any pressure to misreport your results or read too deeply into something that's not there. If you had a really cool hypothesis that would seems it might have produced a really cool result, but you discover something else that says, maybe actually I didn't do this 100% right, and maybe that result could be something else, then it's okay to drop it and say, I did this wrong. I'll try it completely over again. Or say, this isn't going to work. I'm going to take this cool result and discard it because I don't think that's what actually happened. That's a negative result where your hypothesis didn't work out, and that is just as important to research as discovering something new. Proving what doesn't work is 90% of the job. As they say, proper science is the work of disproving, not the work of proving. So don't ever feel a temptation to compromise the ethics of your work, to produce a positive result. And a less intense note, for documentation, then when testing hypotheses, just make sure, like I mentioned, that you limit those confounding factors or document them if they're going on. Things like slow Wi-Fi, for example. And find a good place to keep a track of all the work you've done and list all your experiments. I found Google Doc helpful. When it started getting pretty big, then setting up a local storage with a folder system on a computer helped a lot more to keep everything organized, to put hypotheses and their results in one folder, screenshots of documentation in another. That helped me as well. Whatever system works for you, just make sure that it's resilient and not likely to be deleted. Make sure you have backups for it, and make sure it's easy and convenient to get into. You'll be using it a lot. Seeking funding is like picking a topic in that it's critically important to research and also very difficult to start out on if you're new. It's utterly essential, though. It's so valuable for a resume or a curriculum vitae if you're trying to get into a graduate school or find a job in a company that does research. Then having a grant sponsorship in your history is sort of the best way to prove to someone that you are capable of producing something worthwhile. You can show them, yeah, some other qualified science body looked at my work and said, yeah, this is worth paying for. And that's an excellent thing to be showing employers or professors when you want to reassure them that you are capable of being an asset on a research project. And also, it expands the scope of what's possible in your immediate project. If you only have $100 for, say, my Ring research project, all you can do is maybe buy the security system. And then if you happen to have a laptop, great, you can test that with some free tools. But to do any work beyond that, I mean, to have your own research machine, you'll need more money to buy computers, to buy lab equipment. And eventually, if you manage to get your work into a conference, then you'll want funding to pay for the expenses of it, for the travel and the food and so on. And lastly, grants make research accessible to everyone. Not everybody's got enough money to pay for research out of pocket, and most people don't have enough money to pay for a conference out of pocket. Grant funding is an excellent way to help level the field and make sure that people with great ideas but not a rich background can still access research. So searching for grants can be difficult to get into, but once you start Googling and start going down rabbit holes, it becomes a little easier as you go along. So focus first on opportunities that are believable, that you think you're actually likely to get. kvit.proquest.com, afc.org, hackerinitiative.org are three great websites that I found in my course who all offer excellent grants, which are more importantly targeted towards undergraduate students or even independent researchers, which is ideally the kind of people who are watching this video right now. You don't want to be spending your time applying for highfalutin $500,000 research grants for one summer undergraduate project. Don't waste your time on that. Focus instead on things who are likely going to accept you and put a lot of work into it. Make sure your proposal is good. Research what exactly the funding body is trying to fund and tailor your direction of research towards that, and apply to as many places as you can. If you're coming from a university background, then the best place to start looking for grants is in your own university. Most universities have their own internal research funding bodies who are looking specifically for students from the university to give money to. In other words, they're looking for you. Go search on the website. On the website, you can even look up research in the search bar. Was how I found a number of opportunities. Scout for grants and apply for as many of them as you can. The university, again, is trying to find people just like you, and it would be terrible to waste that immediate opportunity, easier to get than, and spend your time instead chasing outside grants you're much less likely to find. And of course, apply for everything and its grandmother. You never know what you're going to be accepted for. You never fully know what the body is looking for or what kind of work they want to sponsor, and it never hurts. So put your name out there, send your applications to as many places as possible. It's a similar story for publishing and for conferences. Publication is the gold standard for qualifications when heading into research-based jobs like granting, except that it shows not only that you were able to write a convincing proposal for your research, but also that it was peer-reviewed and published, serving as proof that you advanced your field you're in, which is really all anybody could ask for looking for a candidate going into graduate school or a research lab. It's very important for a young student. And there are journals specifically who specifically look for undergraduate style work or that level of research. So don't think that it's all too highfalutin or aimed at high-tech research labs. There are journals you can find. I listed a couple here that were good opportunities for me, and some general resources below that help you search for them. IEEE, its portal hosts a lot of journals. Not all are aimed at undergraduates. They host a lot of publications intended for somewhat high-level submissions, but they have some. And Science Direct hosts a lot of undergraduate-oriented publications as well. So similarly, put your name out there, go anywhere you can. And that brings us to part 2, research tools. This part is oriented more specifically towards network research because that's what I did. But there are a few tools which, in anything to do with networks, come up all over the place. Network jobs, network-related industry, and obviously research. These ones I consider the absolute essentials, and I think you'll find that to be the case too. So we'll cover them here and do some demonstrations, help you get oriented on the kinds of things you'll be using. First, of course, is the backbone of any network forensics or computer-based research, and that's Linux. It's an operating system, as most of you know by now. Alternative to Windows, it's pitched sometimes, but often I find it's more complementary. It's important for network forensics because it contains, well, Linux-specific tools, for one, unique programs that only work on Linux or that have scaled-back versions on Windows. It automates less of the computer process than Windows does. If you want a lot of things done on Linux, you have to start them yourself, which means for a much more simplistic layout, it's a lot less user-friendly, but it's much more helpful for research because you have fewer confounding variables. And it's certainly more permissive of user behavior. On Windows, trying to run most of the programs that you use for more intensive network forensics will result in Windows antivirus quarantining them or shutting off the downloads or flagging them as viruses just because they're a binary, for example. Linux doesn't have any of those problems, and so it's a great place to store and run those programs without Windows shutting them down or compromising them or forcing you to turn off your antivirus. The ideal one for this is Kali. It's designed for it, so it has most of the tools installed and a couple that work only on it. You could get the virtual machine disks for those freely at Kali.org. It's open source, so no need to pay for it. Again, document any changes you make to it, including what kind of the virtual machine you are using, what edition of Kali. Just make sure you keep track of everything that's happening. More of that confounding variable business. IP scanners are next big tool. Advanced IP Scanner and Angry IP Scanner are two most important in this regard. They're both free. I know at least Angry IP Scanner is open source. There's many ways you can find IP addresses of things you're working with, but if some of your devices are, for example, like Ring security devices without a terminal level GUI or direct command access, then it can be annoying trying to find the IP address, and particularly sort out which IP addresses on your network belongs to which device. That's where these scanners come in. They can scan the network you're on and detect which IPs belong to which devices and lay out clearly for you which device is which. I can demonstrate that for you right now. Give me a moment to open Angry IP Scanner. You can see it has a pretty convenient GUI. We will use a pretty small IP range. All right, let's share this. All right, here is an IP range. It's only should scan a couple IP addresses. That's fine. This is just for demonstration. So you find your IP address, network's IP address range, enter it up in here, and these will autofill. So just hit start, and it will demonstrate. There's a threads running. It scans them, and it's found the host computer. It scans complete, and there's nothing on this IP address. And when I have my security system hooked up to the Wi-Fi, then we'll get Ring device right here, or my phone right here, and so on. And it's an excellent tool for just easily finding which device is which in your network and enabling you to do things like targeted scans, use commercial tools like Nessus, or other ways sort out which IP address is which. Next is Wireshark, which is another of those really essential tools for anything to do with network forensics. It is a packet capture, and probably the place that you'll apply most of that knowledge about which IP address goes to which from where I just showed you. It is a bit of a complex tool, so we'll be having a separate video on the channel that goes into just how to use it, but it's well worth learning. It's extremely valuable, and just having a good working knowledge of Wireshark itself can lead by itself to unique research outcomes. We'll have that posted up as well on the YouTube channel, and to download it, it's free and open source. It's available at wireshark.org, so make sure to get that on a work machine. Record, of course, which model it is, which tools you're using on your documentation. And next is Autopsy. It's not a network analysis tool per se. It's examines the computer storage, but it's also essential for most research applications. It's likewise free and open source, and it's used to scan through disks, look at files on a system. It's targeted towards forensics work, but if you're doing research into the security abilities of a device, then it's indispensable for finding if there's useful information just left lying around on the chip or on the disk, and making sure that the programmers did their due diligence in covering their tracks. Again, it's a pretty in-depth topic, so we won't cover it here. We'll have another video on the channel that talks about that. Thank you so much for watching. Those are the fundamental basics of getting started on a research project, or specifically a network forensics research project. And we'll have some more information up on the channel for you to take away and help build your repertoire with. Don't forget that whatever you do in research, as long as it's something new, then odds are it's something worthwhile. Don't get discouraged with no results, and remember to apply to conferences. Thank you for watching, and good luck with your research.